Can you see my slide, please? Will you respond?
Yes, ma'am.
Okay. So students, I think around 35 students are available. I expect a response from all. Okay, so we are talking about a data abstraction, how to build a complex data by using a primitive data. So for this, we have taken an example, rational number, which has a numerator and denominator. Let us say x by y. How to construct this complex data? How to use this complex data for our program? Okay, so we want to apply some logic on the rational numbers. How to do it? So how to build the complex data? How to use the complex data in our procedure? Okay, so that is the topic of today. So we already know some concepts like constructing the pair, right, by using the Cons procedure, right? So shall we apply Cons procedure for constructing a rational number? That is a question mark. Shall we do? By using Cons, can we create a rational number? Students? Initially connecting and then that's all. Your job is over. Just
That
connecting in
is
the
a pair,
internet.
no, ma'am. Cons is a pair, I remember.
Yeah.
Uh, this is a rational number, no, ma'am. So
Mm.
it will be 1.5 is different than 3 and 2.
Yeah. See, now the thing is, I'm not worrying about what is the answer. Okay. But I want to represent this 3 by 2, the rational number. So I can go for a cons. Okay. Taking the first number as a numerator and taking the second number as a denominator. Then later I will manipulate. Let's see. Okay. So, first of all, what is in our hand? In our hand, we have a cons and we have a car, CDR, etc. By using this, we have to go for a complex data construction. Okay, so if by using the concept of cons and by seeing the nature of the rational number, I can go for. I decided that I can. It is nothing but a pair, numerator comma denominator. So I'm using a cons 3 2. Okay. So now consider a rational number r1, rx. Okay. How to? So now I'm going for defining a variable x where x is nothing but cons 3 2. Right. So x is now a little complex data which denotes a pair. It denotes more than one number. Right. It's a collection of a pair of two numbers. Okay, so I can define a variable x, a complex variable, which is nothing but a pair, is numerator and denominator. I'm just printing and seeing, and I will get surely a output of like this. Single quote 3.2. It is nothing but a pair. I can also say it is a list. Yeah. So now, and after that, I would like to retrieve the numerator alone. Okay, the numerator is the first part of the x. So car x will give you 3, right? I want to have a denominator part. So I will apply CDR, right? So now consider, I would like to write a package for manipulating or applying some operations on relational data, relational number. I want to add two rational numbers. I want to subtract rational number, a rational number from another rational number. I want to multiply two rational numbers. I can do many other operations. And I want to construct a small package, okay, which is meant only for the rational number. So what should I do? I just start with this cons and then define a variable. And whenever I want the numerator, I will apply the selector. Car and CDR is called as a selector, right? And cons is a constructor. By using the selector, I can select the numerator part. I can select the denominator part. Okay. So let's take an example how to construct to do rational numbers. Okay, consider it as x, y. X is 3 by 4 and y is 7 by 8. In Lisp, how should I do? So defining x, cons of 3, 4. Defining y, cons of 7, 8. Now I have two pairs. right? These two has to be an element of another z consider. So I can go on like this. Define z and cons of x by where x is the first pair and y is the second pair. So if I look at z is nothing but 3, 4 a list and 7, 8 is the another other two elements of the list. Sorry, the element z. So if I print and see x, y, z, and then what will be the output? I will get surely 3.4, 3478, and 3478. Yeah. So by and after all, if you look at the z is nothing but a complex data. Now I can construct a complex data by using the primitive procedure cons, right? So with this, slowly I'm going for a kind of, you know, doing arithmetic operations on the relational data. Let's look at now. If we apply, we know already this concept, car of x, CDR of x, I will get all those. By using this concept, I'm going for finding the numerator and denominator. Okay, so this also we know car of z, car of CDR of z, what it will give. So if you look at the z part car is nothing but 3, 4, and CDR z part, if you look at it is 7, 8, and car of z is nothing but 3, 4, car of 3, 4. So you will get a 3. So all these operations we have done it already, and you understood as well. Yeah. So what I'm trying to say is, right, the recursive call of the functions will be useful for retrieving a specific element in the complex data, right? So CDR of or car CDR, whatever the combination, I can, by using this combination, I can able to retrieve a particular element in the given complex data, right? So let's go for an example. What I said earlier, the performing operations on relational numbers. What I can do, first operation, I can do the addition, right? Given a rational number n1 d1 n2 d2, you have to add it. So what you will do, this is the one you will do, right? Numerator of the first rational number, multiply with denominator of the second rational number, plus numerator of the second one and denominator of first one, you multiply, sum it, etc., divided by denominator. Okay, so this is the usual practice from the school level. We are performing this. We know if you want to subtract two rational number, this is the thing. If you want to multiply, numerator and numerator will be multiplied, denominator and denominator multiply. Yeah, this is the output. If you want to perform a division, what is that? N1 D2 divided by D1 N2. Right? This is a simple operation we will do. And one more important operation. Given two rational numbers, both are equal or not. How to find out? How to find out given two rational numbers are equal or not? It's a very important operation, right? So n1 divided by d1 is nothing but is equal to n2 divided by d2. When, if and only if you cross multiply n1 d2, n1 into d2 equal to n2 into d1. Yeah, this is the condition. So now I would like to write a program in list which will be performing all these operations with the help of primitive procedures and primitive selector functions. Okay, that alone I have in my hand. So how to perform? Okay, so this is the topic of today. Please look into carefully. Okay, so first of all, what we need, we have to construct a rational number. I'm just going for writing a program, a procedure, rat. Make rat. This is creating a rational number for which I will pass two numbers and consider in this case a numerator and denominator. If I pass these two numbers to the make rat, okay, it is going to give you a pair constructor. What is the internal logic? I'm just constructing a pair with n as the first element, d as the second element. Okay, so this way I can define a pair. Okay, I'm just writing my own program, my own procedure for constructing a pair. Okay, so by which I can able to make a rational number, right? And what else is required for performing the previous operations? Always, if you look at the formula, you look at the formula. So in order to perform addition, what I want, numerator of the first one, denominator of the second one, numerator of the second one, denominator of the first one. So all related to extracting the portion, right? Extracting the numerator or denominator of the given rational number. So I need a filter, right? I need a selector, right? So how to write a selector? I'm going to write a selector. The selector name is numer. Numer is a selector which will be extracting only the numerator part of the rational number. Okay, so inside logic, if you look at it, it is nothing but char r. Numer r, okay, r is nothing but a rational number, it is a pair, okay, so which is created by using a macrat, okay, and char of r will always give you the numerator part. And what about the denominator? I'm just writing another procedure, denominator, which is retrieving the second data, right? Second data, how to get it? CDR of r. Okay, so I have written three procedures. One is make rat, and another one is numer, another one is a denom. These two are selected. This mac rat is a constructor. Right. Now, what is this required? I want to perform all the operations, right? So, how to perform addition of two rational numbers? Again, I will write a procedure. Add rat, taking two rational numbers. Consider it as R1, R2. Yeah. So these two complex numbers are given as an input. Then what I do? So if I look at the logic, okay, so this is my expression, equation, and that one I have to implement here, right? Yeah. So how to implement? I'm just taking numerator 1, okay, numerator of R1. So it will call the previous procedure what I have written, denominator of R2, right? So this part is over, right? And this has to be added with numerator of the second one multiply with the denominator of the first one. Yeah, so I will multiply this one and another term multiply and add it. Okay, and if you look at the another parameter, it is denominator of d1, d2, right? So denominator of r1 and r2, this is another parameter. So if you look at the brackets, you just see carefully add rat. You are going to define add rat taking the parameter r1 and r2 inside the body. Okay, what you are doing, right? So if you look at, there are two parameters. One is this one and another one is a denominator part. The calculation of the numerator part and the calculation of the denominator part as per the equation, right? So now, and in the logic, what I'm doing is, right, I have to construct a pair. I can't write numerator divided by denominator, right? This numerator is the first data and denominator is the second data, and I'm going to construct a pair. Okay, so I'm just calling a make rat again. So in the define or add rat inside the logic, what is that? I'm calling a make rat, making a pair. I'm going to make a pair. See, output is nothing but a pair, right? Numerator and denominator. What is that numerator? It's a calculated part. Okay, so the calculated part is here. Okay, these three lines. Okay, and the denominator part is this one. So if you see the procedure make rat, what is the logic here? You are passing n and d and it will construct n and d, right? So you are constructing a pair, right? So the same way, I'm just writing make rat, okay, make rat and pass two values. One value is this expression, another value is this expression. Okay, so what it will do? It will construct cons with the first argument this one, second argument as this one. Okay, so this is a way I can able to write addition of two rational numbers, right? Okay. Let's take subtraction, how to perform. So if I understand this one, how to add two rational numbers, the same thing I can do it for the subtraction as well, right? So how to perform the subtraction? I have my expression here in my hand. This is a numerator part, this is a denominator part. And I have to construct a pair. So construct a pair by using a make rat, and the first part is this one, second part is this one. Okay, so this is for subtraction. Given two rational number, I will get the numerator and denominator, and correspondingly, I will use this expression and I will construct a pair. Okay, this is for the subtraction. Same way, you can also write for multiplication. Yeah, so how to multiply two numbers? Numerator into numerator divided by denominator into denominator. So that means n1, n2 should be the first element, d1 and d2 should be the second element for the counts. That is for the make rat. Okay, so this is very easy to write. Yeah, and let's go for the division operation. Division operation is very simple. N1, numerator of the first one, denominator of the second one is the numerator. F, numerator of the result. D1 into N2 is the denominator of the result. I'm just making a pair. Yeah, it's very simple. Right. Let's go for testing equality. Given two rational numbers, how to check these two numbers are equal or not? So we have a condition like, what is the condition? Numerator of the first one, denominator of the second one, multiplication should be equivalent to denominator of R1 into numerator of R2. Yeah, so both are equal or not. If you just see the body of this, equal is the relational operator, first argument, second argument, it will give you true or false. Yes, that's what we want. Okay, so these are all the procedure. In this way, I can able to write all the operations. For all the operations, I can able to write the procedures, right? Okay, so now I'm going to take my racket. I'm just going to write this program. And this program already I uploaded in the Teams. You can also open your racket and open that. I have a file called as rat.rkt. Rat is the file name. Rat for rational number. Okay. So now, let's say in my program, what I have first of all, I want to do only addition operation. Okay, I am just going for additional operation. So now what I'm doing is I'm just making a rational number by this procedure what I explained to you. Make rat nd, and inside I have a cons nd. This is for making a rational number. Okay, and to select us to get a numerator value by using char r, and I have a definition of denominator r for getting the denominator value from the pair. Okay, so take another part of the code. I have a procedure for addition, what I explained to you. Define add r, given to two rational numbers, I should make a addition. I should perform addition. Okay, so now I have some variables. I want to define some variables. Okay, I'm just going to define a variable. Define. Can you tell me the syntax? I have defined all these procedures. Now I would like to go for creating two rational numbers, and I want to perform the addition. So how to define, okay, and I say L. L is one rational number, and define L. In order to construct a rational number, I have to call the procedure make rat. In the make rat, I have to pass some data 4, consider it as 6. Okay. Can you understand what I'm saying? So what I'm doing is here, I'm defining a rational number L. L is nothing but 4 by 6. Okay. And L, if I type, I can see 4, 6. And in the same way, defining M or something Q. Okay. LQ. Make rat just say 1, 3. Okay. This is my second rational number. If I type Q and check, I can see 1, 3. So now in my hand, there are two rational numbers, L and Q. That L and Q, I have to add it. Okay, before that, as you said, I'm not getting 1 by 3. It is a kind of, it is a pair. But I want to display the number like 1, then division operator, then 3. So how is it possible? Okay, for that, I'm going to write a procedure called as printrat. Printrat. I go to my slide and explain, and then come back here. Okay, let's look at how to print the pair in the form of x by y. Okay, so what I'm doing is I'm going to define printrat procedure for which I'm giving a rational number. Okay, new line is a built-in, I can say, constant which will be inserting or moving the cursor to the new line. Okay, and then after moving to the new line, I display car of x. So that means the numerator will be printed and then display slash. Okay, so numerator slash display CDR of x, numerator slash and then denominator. I'm just recalling it so that if your variable is 1, 2, it will print as 1 by 2. If your variable has a value 1, 3, it will display as 1 by 3. Okay, that's what you were asking, right? So the same thing I was performing here. The same procedure I have written. Print rat is the procedure and R is the rational number. And then I'm just going for a new line and taking the first value, then printing slash, and then printing the next value. So now, after defining this, I'm just calling this. How to call this procedure? Let's say take a variable L. L is 4, 6, right? So I want to print it as 4 by 6. So how to write a statement? How to write a statement for printing like this? Numerator divided by denominator.
Ma'am, print right as well.
Yeah, print rat. Yeah, at least one student is it. Okay, what I have to pass? L. Print rat. Print rat L, where L is already constructed. So if you are seeing it is 4 by 6, 4 by 6 I am getting. This is the way you want, right? As a human, as a third person, you want to see the rational number in this format. So you have to write a separate procedure in order to display. Okay, this is only for the display purpose, presentation purpose. Nothing much, no logic here. Okay, now I want to define one more rational number. Define L. Okay, let's keep say P. P and then I'm going for calling the display, print rat inside. I have to pass a rational number. So I'm just going to create, and by passing something 3 and 7. Is it right? So make rate of 3, 7, and then I'm just printing it and assigning to P. Shall I do like this? More bracket. Mm. Okay, I just take this alone. Rat of make rat of 3 7 and the bracket if you look at 3 3. Yeah. Expected procedure can be applied to arguments given 3.
Ma'am,
What is the problem? Mm,
Ma'am, you have
ma'am,
put a bracket.
make rat extra bracket is
You can remove brackets 3 and 7. Before 3 and 7, you can remove the bracket.
inside, I think. Just a minute.
Ma'am, there you can't do any modification. You have to once again type it.
Yeah. Which one you are saying? Yeah, correct. So for the make rat, we have to pass 2 arguments. So 3 and 7. Yeah, now it will work, I think. Correct. Okay. So in a recursive way also, while making the pair, you can also display in the form of a rational number. Okay, fine. So now let's go on for the addition of 2 rational numbers. For addition of 2 rational numbers, I have add rat. It takes 2 arguments that are complex numbers, rational numbers, right? So let me add rat and the arguments I just say LQ. Yeah. So you can just say you can verify as well. So given these data, it will be adding. If you want to print in a rational format, then you can just call the print rat. Okay. So now this is the way. If I look at the program, what I have done, I just written make rat for construction, and I have written the selector, and then I have written a procedure for add, right? And then I'm just invoking each and every function. First of all, I will make, and then I will display, and then I will call the add rat for adding 2 rational numbers. Okay, so now the students, you can just write a procedure given the sample code for adding the numbers. You can write a procedure for doing other operations as well. Okay, so now, and one more thing, I just would like to say, if you look at the rational numbers, what I have created, what I have created L. L is nothing but 4 by 6. Is it in the reduced form? Is it in the reduced form? What is in the reduced form? 4 by 6 is equivalent to 2 by 3. Yeah, all right. So you can pass the argument in the reduced form as well. Okay, so how to make 4 by 6 as 2 by 3? What is your logic? How will you reduce the fraction? What is your logic? What we will do is take a GCD of the numerator and denominator. So GCD of numerator and denominator 4 and 6. What is that? It is 24. And then take a numerator part divided by GCD. So 4 by 24. Can you write like that? 4 by 24, 6 by 24?
GCD, no, ma'am, not LCM.
Sorry?
It will be like GCD will be 2, no, ma'am.
Yeah, GCD will do. GCD of 4 and 6, what it will do? It will do the 24, and then you can just use the numerator divided by 24 and denominator divided by 24. Can you get a reduced form? That's what I'm saying.
Yes, ma'am.
24
I'm
is
telling
the
that LCM. GCD is 2, ma'am. Common divisor is greatest one is 2, and then when we divide 4 by 2, we'll be getting a 2, and then
Yeah.
6 by 2 is 3.
Yeah. So what is it? Just a minute. I'm just losing my train. Just a minute. What I have, it is 4 and 6. 4 and 6 is not 24. Actually, it is what is the GCD of 4 and 6?
2, ma'am.
2, right. So 4 by 2, 6 by 2, right? So you will get 2 and 3. Yeah, sorry. So you will get the same number with in a reduced format. So let us modify the previous program. Okay, so what I'm doing is I'm going for the MACRAT, and during construction itself, I will be simplifying the rational number. Okay, so this way I can pass the reduced number to the addrat or subrat. Okay, so before doing an operation, I will be just simplifying the fraction, okay, and then pass the simplified fraction to other procedures. So how to do it? Okay, I have to do some modification into the procedure. I'm just going for a make rat, and I will include a GCD part. Okay, and how to include a GCD part? Let us look at. So what is the what is the code of line you will write? Okay, let's look at. Okay, so take this part. This is a modified version of make rat. The make rat has a cons, but now what we are doing is we are going to assign variable g for which GCD of the given two numbers will be considered. So GCD of n and d I will find out and assign to g. We know the let procedure. The let procedure is useful for assigning the value, and then after assigning it will perform some logic. So this let procedure for which the variable g is nothing but GCD of n and d, where GCD is nothing but a primitive procedure available in the Lisp itself. You no need to find. Okay, it will automatically compute. It is a built-in function, like it is a built-in procedure. This procedure will find the GCD of n and d and assign the GCD to g. And then what it constraint? It constraint numerator by g, denominator by g. So now you get the reduced form. Okay, so what you do is, I already uploaded this code. You just modify the make rat and then tell me the answer. Can you do, students? If at all it is not possible now, less number of students are there, and you are also losing your thing. So why we should try? We should attend the class. We should alone attend the class. Why? So the question may arise. Okay, so now what I'm saying is here, the part that the point to notice, you want to modify something. What you're doing is you are going to the lower level and you modify the procedure, and you are not modifying add rat, subtract rat, multiply rat. You're not modifying. After all, if you look at the procedure how you have written, I just show you. Look at our procedure. First of all, in the lower level, we have cons, car, and CDR. With this, we are going to make a rational number. We are going to write a procedure numerator and then the denominator, which will fetch the numerator and denominator part in the constructed rational number. And then by using this, okay, we are writing add rat and subrat, mult rat, etc. Okay, and then your package may consist of all these. Okay, so you want to write a big program which will do all the operations on the rational number. What we will do? You will just call the add rat, but in the underlying part, you will not feel what is written, how the rational numbers are implemented, how we are getting a numerator part, how we are evaluating the expressions for add rat. Nothing is known. You just call only add rat. Okay, so if you want to perform some, you want to update some logic in this part, you can always do. Okay, that will not affect the higher level part. Okay, this is called as a modularity, abstraction. Okay, so suppose I want to modify the data type. Here I can, suppose the language is providing something else, I can write it over here. Okay, depends on the data type. I will write this numerator part, denominator part, etc. But add rat and subtract rat will always work. Okay, so this is nothing but a concept of called abstraction. Okay, so if you modify something in the lower part, okay, you no need to worry about the upper part. Upper part will work. You just modify it. It's a kind of modularity. Okay, so depends on the data type what you are taking in the lower part. Just modify only the just higher level part. You no need to modify everything else. Okay, so that is what we are doing here. I wanted to make a logic of make rat just by modifying without modifying the add rat. Okay, that is the concept of abstraction. Add rat does not worry about what is the logic you have included in the make rat. Okay, so this is a way of writing the program. So now you go to the make rat function, modify it, and include the GCD logic, and then construct n divided by g and d divided by g, and then call the add rat. Okay. So, any doubts so far? We are talking about the building complex data. Building complex data using the cons and the car and CDR part, and we have taken a rational number and how to perform operations on rational number with the available primitive procedures available. Yeah. So these are all the procedures we can write with respect to rational numbers. I can add, subtract, multiply, divide, and I can check for the equality. And for all these operations, we can easily write the procedures in abstract format. In this way, we are splitting the program into layers part. Okay, so that if you change some modification in the lower part in the bottom level, it will not affect the higher level. Okay. So any doubts in this?
Ma'am, excuse me.
Yeah.
Ma'am, in the like beginning of the session, you showed a place where cons of the rational number was used. Like, uh, can you please go to that slide?
Which one?
Before the procedures.
This is the one.
No, ma'am. Before we started the operations. Yeah, before this. Here, ma'am.
Mm-hmm.
Ma'am, this one. Why is why when we are printing Z, the last statement, why are we not getting it as two separate pairs, ma'am? Like, why is the
Oh,
first?
okay. This 7, 8 is not considered as a pair. That's what your question, right?
Yes, ma'am.
There is no bracket. Okay. See, the Lisp is actually, if you just put a bracket here, what CDR will do? CDR is going to construct a pair from the second onwards to till the last. After all, we are talking about the pair. So the second one is internally it is a pair only. Okay, if you apply the car 3.4, it will come. So you just denote only the first element. The CDR will take the next element onwards, right? It will understand the second onwards. So anyway, CDR will return you second to the last, where second to last is one of the list. So if you apply the CDR to this particular Z, you will get 7, 8 as a list only. But internally, it is saving like this, but it is well aware that this is a list.
Okay.
Yeah.
Yes, ma'am.
See, that's why car of Z, See here, car of Z is 3, 4. CDR of Z is 7, 8. It is always returning as a list only. Okay.
Yes, ma'am. Thank you, ma'am.
Okay, students, and actually we are making a difficult subject, making it easier by teaching the small portions. We are concentrating more on that, on the concept and taking a portion of the textbook and we are explaining. I hope you can able to follow it up. But your task is you have to take a exercise and do it. Just see the exercise. Okay, after reading and understanding, take the exercise and whether you can write a program for that. That is important. And the answers are also available in the website, the textbook website, the author website. It is provided, I think. All the answers are available. So through practice only you can do. See, this is we have taken a rational number. What if you are taking a polynomial? Yeah. So two polynomials you have to add. What you will do? Polynomial of which degree? So it is a little higher concept. Okay. So just think the logic for a polynomial. So you can very well tell your logic what are the procedure you will write, how to fetch the what is that magnitude of each and every variable, right? Ax square plus bx plus c is a given polynomial. How will you retrieve a? How will you retrieve b? After all, how will you represent the polynomial with a degree 2? Whether cons is fine. Cons will always take two values, but in the polynomial of degree 2, we have three data. So which data structure you will go for? Okay. So the logical thinking always must be applied. You have to think. So what we can do? Okay. So let us discuss anyway the next portion of this particular topic. Thank you so much.
Thank you, ma'am. Ma'am, also there was SOTI exam at 9, ma'am. You were like Shriba ma'am was